All right, good morning, good afternoon, good evening, whatever time zone you hail from. This is my initial post for week 4, unit 4, initial post for the discussion. My position, I'm going to be focusing on the thin client. Today's rapidly developing technological environment argues in favor of using the thin client approach for software architecture for various reasons. A thin client system puts most of the computing power onto one or both server sides. In contrast, clients primarily serve as interfaces, providing more computing resources on either server side than the client. Let us examine both the client and server-side programming and network load regarding this approach. So the server-side programming. When designing the thin client architectures, servers take on most computational tasks for better scalability and maintenance. Server-side programming entails developing logic, algorithms, and data processing capabilities necessary to process client requests efficiently. Examples include cloud applications, web systems, and online banking platforms. Here, servers take care of the data storage processing security concerns, while clients focus on rendering the UI elements while handling interactions from users. Moving on to the client-side programming. In thin client architectures, clients' roles provide users with a lightweight interface to interact with server resources. Client-side programming primarily targets the presentation layer and user experience issues. Modern web apps rely heavily on client-side technologies like HTML, CSS, and JavaScript and client programming for rendering dynamic content, handling user input, and light data processing tasks without burdening the server, freeing up to focus on the complex business logic while serving multiple clients simultaneously. Moving on to network load. One key benefit of the thin client computing is reduced network load. Since most computing power resides on the server side, clients' transmission needs for data are minimal. The server manages resource-intensive tasks like data processing and storage, and eliminating the need to transfer large amounts of information back and forth between client and server. For example, this can be especially advantageous when clients have limited network bandwidth or access it remotely. Current systems that take advantage of reduced network loads include cloud-based productivity suites like Google Docs, allowing users to collaborate in real time without incurring as much data transfer overhead. Overall, the thin architecture offers numerous advantages to modern software architecture. By centralizing computing power on the server side, this method creates a more scalable, maintainable systems with server-side programming handling complex data processing and storage needs. In contrast, client programming addresses user interfaces and presentation needs. In addition, the reduced network load enhances performance while accommodating clients with limited bandwidth, staying relevant with technology changes while building efficient information systems that remain responsive to the end users. I thank you all for listening to this initial post, and if you have any questions, please feel free to comment in the post. Thank you.